Hello everyone and welcome to my Thermo II final project. My paper is called Vapor-Liquid Equilibrium and Extractive Distillation for separation of azeotrope isopropyl alcohol and diisopropyl ether. Here are some background of the paper. Isopropyl alcohol, or IPA, is a good solvent for the pharmaceutical industry. The production of IPA contains a byproduct called diisopropyl ether, DIPE. IPA and DIPE can form a homogeneous azeotrope at atmospheric pressure. It's difficult to separate such an azeotrope by conventional distillation. This paper applies extractive distillation to separate azeotrope IPA and DIPE with the extractive solvent 2-ethoxy ethanol and butyl acetate. There's a constant pressure of 101.3 kilopascals. The thermodynamic consistency test was validated by Harrington and Van Ness test. NRTL, Uniquac, and Wilson activity coefficient models were used, and based on the results, a conceptual extractive distillation process is proposed. The significance of the paper is listed here. The isobaric VLE data for the system of the following were measured at 101.3 kilopascals. The root mean square error, RMSD, of vapor composition and temperature were less than 0.0062 and 0.44 Kelvin. Based on the analysis of relative validity, 2-ethoxy ethanol was selected as the extractive solvent. A conceptual extractive distillation is proposed, and the IPA purity measured at the exit stream was 99.7 mol%, and the DIPE purity was 99.9 mol%. My question for this paper is, instead of using NRTL, Uniquac, and Wilson activity coefficient models, what if we used modified Raoult's law to predict the activity coefficient for the DIPE and IPA mixture? How much would the results change? To do this, we first need to remind ourselves that modified Raoult's law has the form of YIP equal to Xi gamma I Pi sat. Next, we need to calculate the saturation pressures based on Antoine's equation for each species. Here are the Antoine's equation parameters for each of the species. Using the given temperature, Xi and Yi values from the paper, I was able to construct an Excel sheet for my calculations. After that, I graphed the results with X1, Y1 on the x-axis and gamma values on the y-axis, and compared it with the data in the paper. This figure on the left is my Excel data, and the figure on the right displays the gamma values from the paper. As we can see, the gamma values from my data are the same compared to the gamma values from the paper within 1 decimal place. However, they start to deviate at the 2nd or 3rd decimal places. Here's a comparison of my gamma 1 value with the paper's gamma 1 value in a clustered column chart. As we can see, the differences for each value is very small, indicated by the graph. If we compare gamma 2 values, we also get a similar result. Therefore, based on the data and graphical comparisons, we see that the gamma values calculated with modified Raoult's law only differ slightly from the values calculated by models such as Uniquac. This leads me to believe that had this paper used modified Raoult's law, they would have gotten a similar result. However, the exit stream purity of final conceptual extractive distillation model could decrease slightly. That's the end of my presentation. Thank you for your time.